Greetings everyone. We will continue our discussion on programming for problem solving using C. In the previous sessions, we have started about pointers and how to perform dynamic memory allocation by using pointers. In this session, we will be going for a new topic called as preprocessor and how to implement the preprocessing by using preprocessor commands or preprocessor directives. So first we will be looking about what is preprocessor, then we will be looking about what are the preprocessor commands we have. So a preprocessor is a program that processes our source code before it is passed to the compiler. So there is a step in your particular compilation, that is the programming steps is you will be having editing, okay. So these are the programming steps or the steps used to run your particular program in a computer. Usually you will be first performing the editing part with a text editor, then you will be performing the compilation, then you will be performing the linking, then you will be performing the loading, where the particular program will be given to the CPU for your execution. But there is a particular program called as the preprocessor which will be present before your compilation process, okay. So the preprocessor is a program that processes our source program before it is passed to the compiler. So whatever that the code you write or the source code you write, it has to go through the preprocessor. The preprocessor modifies the source code accordingly and it will provide that particular source code to the compiler, okay. So the preprocessor will exist between your text editing and your compilation part. So the preprocessor works on the source code and creates an expanded source code. So the input is, you will be getting a source code and the preprocessor provides the expanded source code which is presented to the compiler for compilation. What is this expanded source code you will be learning? So this is an implication. You will be writing your source code. That particular source code will be provided to your preprocessor. The preprocessor will create or add existing codes and it will provide an expanded source code. That expanded source code will be provided for the compiler for compilation process. What is this preprocessor and how it provides the expanded source code we will be seeing. So the preprocessor offers several features called as preprocessor directives or preprocessor commands. In order to perform this preprocessing, okay, this preprocessing will be usually done because we are having the preprocessor directives or preprocessor commands in our language. So the preprocessor offers these features, okay. These features will be calling them as preprocessor commands or preprocessor directives. Each of these preprocessor directives will begin with a hash symbol. So far you have been using some of these preprocessor directives. So all those preprocessor directives will start with a hash symbol. The directives can be placed anywhere in the program, but most often placed at the beginning of the program before the main function. Okay, before the main function we will be having these preprocessor directives. You can write those preprocessor directives anywhere in the program inside the main as well, but usually these are written above the main function, okay. So the various preprocessor directives are grouped into the following types. The first type is the file inclusion. So the file inclusion will be done by using your hash include, which you have been doing so far. So the file inclusion is one type of preprocessor directive. The second type of preprocessor directive is your macro expansion. The macro expansion is done by using hash defines, and we are having compilation expansion or conditional compilations. So these conditional compilations will be like if def, end if, okay. So this will be done by using this if def, and we are having other directives like your undef, pragmatic, okay. So those will be discussed one by one now. So the first part is the file inclusion part. The file inclusion will be used to include one file into another file, or it simply causes the entire contents of one file to be inserted into the source code of the another file. So you will be writing at the starting of the code like hash include stdio.h. So this is the include, that is your file expansions. You will be including files here, that is you will be specifying the files. So those files have to be included into another program. That is, if I am writing a program and you are writing hash include stdio.h, what you are saying that particular stdio.h header file contents how to be included in my program. So one file will be presented into another file. The entire contents of that file will be copied into this particular file. What your preprocessor does is, it will remove this line from your source code. So initially in your source code you will be writing this hash include stdio.h. What your preprocessor does is, it will remove this particular line of hash include stdio.h and it will bring the complete stdio.h header file contents into this position. Okay, all the file contents will be moved into that particular position. The source code of stdio.h will move into that particular position. This is what your preprocessor does. The preprocessor will replace the preprocessor commands with the source code of actual contents. Okay, so these file inclusions, we are going to do the file inclusions for various reasons. The first reason is, if we are having a very large program, the best is the code is divided into several different files, each containing certain set of functions. These files are then included at the beginning of your main program. Okay, so if you are having a large program and you are going to break down the program into parts, each part containing certain set of functions. Okay, so if you are writing the main program, at that time you can include all the subsequent parts. Okay, so when you are dealing with large program, you can divide that program into files and you can write some certain set of code in that file and include that particular file in our main program. So in that place you can be using your file inclusions. And the other places there are certain commonly needed functions and macro definitions that can be stored in a file, and that file can be included in every program we write. Okay, so far you have been doing for this purpose, where some commonly used functions or macros will be included in one file. So if you are writing math.h header file will contain all the commonly used mathematical functions in that particular header file. Okay, that is why we will be creating the header file so that we can include it into our programs. These are the reasons why you will be having the file inclusion. The file inclusion can be done by using these two types, that is, one by using the codes, another by using your less than or greater than symbols. Okay, so you can do the file inclusion by using these two statements. When you use this particular statement, that is by using the codes, it searches for a file named goto.h. For example, if I am writing hash include goto.h, it searches for a file named goto.h in the directory containing the current file. Okay, if you are writing a particular program, if this is a program add.c, I am writing hash include, okay, some x.c. Okay, so you will say, when I include this particular file in my program, the compiler is going to, the preprocessor is going to check for that x.c in the current directory where your adds.c program is present. Okay, it is going to search for x.c in the current directory, that is where you are having your files, that is you will be having add.c, x.c and other files in the current directory. It will search for that particular x.c in the current directory. If it is present, it will include. Okay, and your hash include file name, this particular declaration will be used when it searches for the file name go.h in standard list of system directories. Okay, it will contain set of system directories. Those system directories, this particular thing is going to search for the file in those system directories. Okay, so you can include your files by using both these statements. That is, you can use quoted file name, or you can use this particular type. If you are using this, it is going to search for this file name in the current directory. If you are using this, it is going to search for the file in the standard directory for your C language. Okay. So the second type of your preprocessor directive is your macro expansion, where a macro is a fragment of code which has been given a name. Okay, if I am having a code, you can give a name to that code and place it as a macro. Wherever the name is used, it is replaced by the contents of the macro. So in the main program, wherever you use that macro, the contents of the macro will be placed here. For example, so there are two types of macros. One is object-like macros that will represent, that will be like data objects, and you will be having function-like macros which will be like a function calls. If you see, the first type is the object-like macro. The second type is this is also an object-type macro. So this will be done, that is the macro expansions will be done by using #define. Okay, so your file inclusions will be done by #include, your macro expansions will be done by #define. So this is a macro where you are defining #define x4. Okay, that is wherever I use x value, it will be replaced by 4 in the pre-processing. That is, this is the source code and you are using x here. Okay, what your preprocessor does is, it will remove this line and it will place 4 value here. Now 4 will be assigned to A. Okay, in a similar sense, you can use this #define pi 3.14. So wherever in the program, if you use pi, it will be replaced by 3.14. So this is a macro, and we'll be calling this as macro expansions, where a macro will be defined and that particular macro can be used any number of times in the particular source code. Okay, during the pre-processing time, wherever that particular macro is used, that macro will be replaced by the value you are specifying here. So here I am placing x as macro, and wherever you use that particular macro, x will be replaced by 4. And here also, wherever you use pi, it will be replaced by 3.14. Okay, in that manner you can use your macros to define some constants. This is an object-like macro. In the same sense, we will be having function-like macros where you can define functions. This is #include stdio.h. Here you are defining function #define my minimum min of a comma b. This is a function macro, and inside that function macro, what you are writing, a is less than b means a, otherwise b. You are writing this code. A less than b means a greater than b means b. So if this is true, it will return a. If this is false, it will return b. So we have written a function code or a function macro. Okay. So wherever you can use this function macro any number of times inside the main. You can use this function macro any number of times inside the main. So wherever you used that particular macro, okay, that particular macro will be replaced by the code. Okay, so now it will be replaced by 10 less than 20, 10, 20. Okay, so this is how it will be replaced. So this is what we will be calling it as the macro expansion. This is a function type like macro, where we will be writing a function and the corresponding code. Wherever you use that particular macro, it will be replaced by the function code. Okay, this is a macro expansion. So another type of thing is, you will be having undef. To undefine a macro means to cancel its definition. This is done by using the undefined macro. So we have already defined some macros by using #def. Okay, you can undefine it by using hash undef. You can undefine it by using hash undef. So whatever macro you have defined, if I want to release the particular contents and I want to move or I want to undefine that particular thing, I can use undef. So this is an example of your undef, where you are writing the first statement as define pi 3.145, and immediately what you are doing undef pi. So now this definition is completely removed. Okay, when I write undef, this definition will be removed now. Okay, now when I try to use the particular thing pi, okay, you will be getting an error, compile time error, pi undeclared. So you can define one particular macro and you can undefine the macro by using undef, based upon your convenience in your programming application. Okay, so that is about def and undef, which are macro expansions. Then you are having conditional compilations. So this allows to include certain portion of the code depending upon the output of some constant expressions. Okay, you can implement the conditions. So based upon the conditions, one certain part of the code will be included into the program. Otherwise, other part of the code will be included into your program. It is just like your if-else statements, where if the particular condition is true, the true blocks will be included into the code. Otherwise, the false blocks will be included into the code. So to implement that, we are having if def. Excuse me. The if def preprocessor directive checks if the macro is defined by the definition or not. Okay, whether there is a definition or not will be checked by if def. If def is a preprocessor directive to find out whether there is a definition or not. If yes, it executes the code, otherwise else code is executed. Okay, if present. So this is a code where you are writing hash include stdio.h, then you are defining hash define num10, hash define num10. That is, I am defining one macro and I am initializing the value to 10. Then I am writing the main. Inside the main I am checking the condition if def num. If def num means whether there is a definition for num or not. That is the meaning here. Whether there is a definition for num or not. If there is a definition, then that is a true statement. Then define max 20 means I am defining another macro with max and giving value 20. Okay, if this is false, that is there is no definition for your num, then else block, if there is an else block, that else block will be executed. Okay, if there is no definition here, then else block can be executed. That is, you can write else like this, hash else, and I'll separate code. Okay, hash define max is equals to 30. You can write in that manner. So if def means whether the particular definition is present or not. That is, the number has a definition here. So this is a true statement. So true means this particular statement will be executed. That is, max will be given a macro of 20. Macro max will be created and the value 20 is there. And if I print max number is max, so 20 value will be printed. If I do this thing, if there is no definition, then this is false. At that time, the max value will not be printed like this. Okay, you will be getting an error that max is not declared. You will be getting an error that max is not declared if there is no definition here. So the opposite of this is if ndef, if there is no definition. In the previous thing, here you have checked whether there is a definition or not. If there is a definition, that is true. This is the opposite if ndef, that is, if there is no definition, then that is true. Otherwise, it is false. If there is no definition, then that is true. Otherwise, it is false. Okay. So hash include, here you haven't defined anything. Okay. Here you haven't defined anything. And the condition is if ndef. Ndef means no definition. If there is no definition for num, so there is no definition, I am initializing max to 20. Okay, at that time max will be printed to 20. If there is a definition, that is if I have a definition, hash define max, the number definition, that is hash define num10. If there is a definition, at that time this will be false and there is no else block will not be executed, so there is no max, so you will be getting an error that max is not declared. So this is how your if def will work and if and def will work. If definition, if no definition. So that is a conditional compilation you can do. So this is an example of your basic if else, that is if else for your conditional compilation. Initially what you have done, hash include, then hash define a 100, that is gave a as 100. So if a is equals to 100, then since this is a macro, a will be replaced by 100. If a is 100, this line will be included, because a is 100, this will be printed, else this will be printed. So this is how your if end if conditional compilation macro will work. Okay, these are the various conditional compilation macros you are having. You can write any number of statements in this manner for performing various conditional operations in your program. Okay, all these things will be processed during the pre-processing time itself. If you are writing the basic if-else statements, they have to be processed during the compilation. This will be done during the pre-processing itself. Okay. And the last type is your miscellaneous directives, where the main important thing is the Pragma preprocessor directive, which is used to provide additional information to your compiler. So the Pragma preprocessor directive will be used to provide additional information for your compiler. It is used to call a function before and after the main function call in a C program. If I want to have a function call before the main function and after the main function, not the writing part, if you want to call the function, usually the C program has to be called from the starting of the main. Okay, if you can use the Pragma directive to call your function before the main, and you can call a function after the execution of the main as well. So if you see, this is a program where you are having hash include stdio.h, and you are declaring two functions, function 1 and function 2, and you are defining those functions here, function 1 and function 2. Function 1 is called, okay, function 2 is called. Okay, these are the two functions, this is the declarations, these are the definitions. Here if you see, you are having a Pragma directive. What you are writing? Pragma startup function 1. Startup function 1 means the function 1 has to be executed or called before the main. This is the information you are providing to the compiler, that is the function 1 has to be called before main. So what will happen? Before this main is called, the function 1 will be called and you are going to print this particular statement. Okay, then the main function will be called inside the main function. Now we are in main function statement will be printed. So you are saying Pragma exit function 2. Exit function 2 means after the main, during the exiting of the program, I have to execute function 2. This is the information I am providing to the compiler. That is, after exiting the main function, I have to execute function 2. So the function 2 will be executed after the main. So it will be printed function 2 is just called. So in this manner, the Pragma directive can be used to provide some information to the compiler whether to execute a program before the main or after the main. Okay, so here you have specified function 1 should be executed before the execution of main and function 2 should be executed after the execution of main. So in this manner we will be getting an output, that is function 1 is called before function call, main function call, and now we are in the main function. Why? Because after this main function will be executed. Then after the main function is executed, I am giving the Pragma exit, that is function 2 is called just before the end of your main function. So in this manner you can use the Pragma directive to provide some additional information to the compiler. So whether to execute a function before the main function call or at the end of your main function call. So these are the preprocessor directives you are having as a part of C language, and you can use these preprocessor directives and they will be executed and they will be done by the preprocessor, and the extended code will be, that is whatever you write, they will be replaced by the actual code and they will be done by the preprocessor. All this conditional compilation and Pragma things all will be done by the preprocessor, and then only the extended code will be given to the compiler. So this is about your pointers and preprocessor directives. Thank you.